Okay, here's example 5, finding the area of any regular polygon. In this case, we are given a regular hexagon with the apothem being 2 times square root of 3 inches. Now, the apothem is the distance between the center to any one of the sides of the regular polygon shape. So from the center here, maybe all the way down to this side, and they intersecting each other perpendicularly. So that's going to be the right angle right there at the point of intersection. And of course, you can draw this to any one of the other side in the same fashion. Now, the formula for the area of any regular polygon is 1/2 multiplied by the apothem multiplied by the perimeter, but we don't know the perimeter, so how do we find that? Well, to find the perimeter means that we have to find all sides and we add them together. Now, to find the size of this regular hexagon, we had to chop this regular hexagon into different triangle in the green. And we can do that by creating the lines from the center to all the vertices of this regular hexagon. So from the center to this vertex, or to this corner point, I should say, to this corner and to this corner. So we got 6 different triangles. We have the regular hexagon. By its definition, it is not just equilateral, it is also equiangular. So this angle is the same as this angle, the same as this one, the same as this one, the same as this one, and the same as this one. So with the green line from the center all the way to all of the vertices, each of these green lines is bisecting the respective angle of this regular hexagon. So whatever the degree of this angle is, which is the same as all of the other ones, this half is going to be equal to this half. So how do we figure that out? Well, we can figure it out by recognizing that if we were to start from one point and we go all the way around back to the starting point, that's going to be equal to 360 degrees. Because remember that when you go all the way around, that's 360 degrees. So you start from this point, you go all the way around, that's 360 degrees. But because this is a regular hexagon, we know that this angle is going to be the same as this, the same as that, the same as that, the same as this one, and the same as this one. So we got 1, 2, 3, 4, 5, 6. We got 6 interior angles here, and the total degree that we go all the way around is 360. So we got 360 divided by 6 of these angles. It's going to give us 60 degrees for each of these angles here. Like that. Well, if this is 6, if this right here is 60, then by the theorem of alternate interior angle, this also has to be 60 degrees. If this angle is 60, then by the same alternate interior angles theorem, this is also 60. And of course, you guys can, figure out the rest. This is 60, 60, 60, 60, 60 right here, 60 right here, 60 right there, 60 right there, and right here. You see? So 60 all the way around. We can go ahead and try to evaluate the side denoted by the lowercase s. The way we evaluate the side is going to have a lot to do with selecting one of these green triangles and then select one of its half. So with the bottom one already drawn out right here, I'm going to select the bottom green triangle, and I'm just going to go ahead and select the right half. Because what I'm attempting to do is that I'm attempting to use the 30, 60, 90 triangle property, evaluates this half, and then eventually I'll be able to, evaluate the S. So let's pick the bottom one, the green triangle, and let's just say I'm going to pick the right half, like I mentioned. So right there, and right here, sketch it out a little more. And we got this right here. Well, we know this angle is 90. This angle here is 60 degrees, but because this green line, which is the radius of the circle, is bisecting this angle, we know this half. We know this one is going to be 30 because this angle is only half of this entire thing. So we're talking about this half here, which is this one. Sorry about that. Well, we know this is 60. I mean, this half has to be 60 as well. So yeah, it's 60. Sorry about that. But we got 90, we got 60. This has to be 30. We know this is going to be 30 because this angle here got bisected by the apothem. So this half, this right half, which is this one, is 30. Now by the 30, 60, 90 triangle property, opposite to 30 degree is the short leg denoted by a variable. We call it x. Opposite to 60 is the long leg in the red denoted by the formula x times square root of 3. The short leg times square root of 3, and opposite to 90 degree is the hypotenuse in the green denoted by the formula 2 times x. The apothem in the red is equal to 2 times square root of 3. So really we set this equation equal to 2 times square root of 3. Well, guess what? When you have identical terms on both sides of the equal sign, they cancel out. So we're left with just x equal to 2. So we know this is x equal to 2. But then again, this x here is only half of the entire base, but the entire base is denoted by the letter lowercase s. So technically we got 2 equal half of s, which is s divided by 2. So looking at this here, multiply both sides by 2 to get s by itself, we know that s has to be equal to 4 inches. And this is the side of this regular hexagon. Well, with the side being 4 inches, but we got 6 sides. So adding all 6 sides together, we know the perimeter is going to be 24. So we got 1/2 times 2 square root of 3 times 6 times 4. 4 here is the value of the side, of each side. 6 here is the amount of sides that we have, which is 6 of them. So let's see. This one here cancel out. 6 times 4, 24. 24 times square root of 3 times 1 is just going to be 24 square root of 3 inches square. And this is the area of this regular hexagon.